solution of the second question. So the question says that find the terms up to x minus x naught to the fifth power in the series solution of y prime plus 4xy is equals to 3e x minus 1. Given an initial condition of y of 1 is equals to 1. Okay, as I explained earlier from the first video, the value of your x in this situation is the imputation of the initial condition of your y. So here our x is equals to 0, our x naught is equals to 0, is equals to 1. Our x naught is equals to 1 from here. So now to solve this question, the first thing I'm going to do is to make the highest power of your differential the subject of the formula. So looking at this question, we know that the highest power of our differential is y to the first differential. So making the subject of the formula gives us y prime is equals to 3 exponential x minus 1 minus 4xy. Okay, so that is what it gives us. So the next thing I'm going to do is to impute the initial condition into the equation that you've gotten. So imputation of the initial condition gives us that y of 1, y prime of 1 is equals to 3 exponential 1 minus 1 minus 4 times 1 times the value of our y, which is also 1. So this gives us 1 minus 1 is 0, the exponential of 0 is 1. This gives us 3 minus 4, which gives us negative 1. So the next thing we're going to do is to get the second differential. So the way to get the second differential is to differentiate this. So differentiating this equation gives us, if we differentiate y prime, we're going to have y prime prime. And now the problem, we have a little problem here. How are we going to differentiate 3 exponential x minus 1? Okay, I want you to know that this 3 exponential x minus 1, another interpretation of it means that 3 exponential x over e. Okay, so from the law of our indices, okay, that's how this was got. Okay, from there, we know that this means 3 over e exponential of x. So this 3 over e exponential of x, if you check your calculator, e has a value in your calculator. And of course, if you divide 3 over the value of your e in your calculator, you are going to have a number. So that number is a constant, okay? So now if you differentiate if you differentiate the exponential of x, you're still going to have an exponential of x. It's only the exponent of x that is differential, and the integral gives you the same value. Okay, so what we have, differentiating 3 over e exponential of x will still give us 3 over e exponential of x. Now for this one, use a product of some functions. So the next thing I'm going to do is bring out the coefficient of the product. So the coefficient of this product is negative 4. So you open a bracket. Now you are going to use your product rule. Hold one and differentiate the other. Afterwards, you still hold this one and differentiate this one. So holding x and differentiating y gives us y prime. Then holding y and differentiating x gives us 1. So by expanding, we have that 3 over e exponent of x minus 4xy minus 4y. So the next step you're going to do is to impute the values of your, is to apply your initial value into this equation. So by the imputation of our initial value gives us that our y prime prime of 1 is equals to 3 over e exponent of x is actually going to be 1. So 3 over e minus 4 times 1 times the value of our y. What's our y? Our y is 1 minus 4 times 1. So from here, e can cancel e. We have that 3 okay, sorry, this is y prime, and y prime is negative 1. Okay, so 3 plus 4 minus 4, which gives us 3. Okay, from here, negative 4 times xy prime gives us negative 4xy prime. Negative 4 times this gives us this. Then 4, of course, for x is 1, and y prime is from the first one that we saw, our y prime is negative 1. That's how negative 1 came about. So we get 3. Now the next step is to differentiate this term so that we can find the value of our third power, our third differential. So let's know our third differential, which is y prime prime prime, is equals to, if you differentiate this term, you're still going to have, the same thing, because the differential of an exponent is the same as its integral. So this gives us 3 over e exponent of x minus, bringing out the coefficients of this product gives us negative 4 exponent, holding 1 to differentiate the other gives us x y prime prime plus y prime times 1. Like I held x to differentiate y, and I also held y prime to differentiate x. So minus, differentiate 4y prime, 4y is going to have 4y prime. So by expanding, we have that 3 over e to the x minus 4x y prime prime minus 4y prime minus 4y prime. So by applying the initial imputation of the initial states, by imputation of the initial values gives us our y prime of 1. Our y prime of 1 is equals to, of course, whenever we see e, whenever we see x, right? Whenever we see x, we know that our x is equals to 1. So we have 3 over e to the 1 minus 4 times, the value of our x is 1, times the value of our y to the second differential. The value of our y to the second differential is is 3. Then minus the value of our y to the first differential is negative 1. So we have 4 times negative 1, and of course 4 times negative 1. So by expanding, we have, so this can cancel this. So we have that y prime prime of 1 is equals to 3 minus 12 plus 4 plus 4. Okay, so 3 minus 7 plus 4 plus 4 gives us negative 1. So it gives us negative 1. Okay, so to get the value of our fourth prime, so the value of our fourth prime, y to the iv, is gotten from the value of our third prime. Okay, so if you differentiate your third differential, you're going to have a fourth differential. Then, of course, if you differentiate this term, you're going to have the same thing. So if you differentiate this term, first thing, bring out the coefficient of the product. So the coefficient of the product is -4. So that will be -4 in the bracket. Hold one and differentiate the other. So holding x to differentiate y gives us y to the third power, the third differential, plus holding this to differentiate x gives us y to the second differential times 1 minus 4. Since y is the first differential, differentiating it gives us y to the second differential. Likewise, this gives us 4y to the second differential. If you like, you can add them together, you can still use them. So applying the initial condition gives us y to the iv of 1 gives us 3 over e because x is 1 minus, okay, let's expand this before the imputation. So we have 3 over e to the x minus 4xy prime minus 4y prime minus 4y minus 4y prime. Okay, so by implication of our initial condition gives us 3 over e minus 4 times the value of our x is 1. The value of our y to the third differential is -1 minus 4. The value of our second differential is 3. 4 times 3. Okay. Minus 4 times the second differential of y, which is 3. 4 times 3 minus 4 times 3. So of course this cancels out. We have that 4 times -1 gives us -4, so times this will give us +4. +4 minus 12 minus 12 minus 12. So this gives us -36. That will give us -29. So it gives us -29. So the last but not the least is our fifth differential. So our fifth differential is gotten from the differentiation of the fourth differential. So differentiating this gives us the y to the fifth differential is equals to, if you differentiate this value, you're still going to have the same thing, because if you differentiate an exponent or integrate an exponent, you're going to have the same value. So you are going to have e to the x. Actually, there are other methods to differentiate this. There are other methods to differentiate. You can use substitution, that's chain root it. Okay, so we have, if you differentiate this, the first thing I'm going to do is to bring out the coefficient of the product, which is -4. So differentiating, if you hold one, differentiate the other. So if I hold x and I differentiate y, I'm going to have y to the fourth power plus, if I hold y to the third differential and differentiate x, I'm going to have 1 minus, if you differentiate y to the second differential, I'm going to have y to the third differential, and of course these ones as well. y to the third differential and y to the third differential. Okay, by expansion, we have that y to the fifth power is equals to 3 over e into the x minus 4x y to the fourth differential minus 4y to the third differential. Of course, we have they are the same, so I can see negative 12y to the third differential. Okay, for this. So by imputation of our initial condition gives us that y of the fifth differential of 1 is equals to 3 over e minus, because x is equals to 1 here. Okay, so you have 4 times x is 1 times y to the fourth differential is negative 29. So negative 29 minus 4 times y to the third differential. Our y to the third differential is negative 1. Negative 1. Okay, then minus 12 times y to the third differential, which is still negative 1. So you have negative 1. So by imputation, we have that the value will give us 135. Gives us 135 by imputation. So the last step you're going to do is to take the values of everything I've gotten and imputing it into the Taylor series. So recall that the Taylor series y of x is equals to y of x naught plus x minus x naught y prime of x naught plus x minus x naught over 2 factorial y prime prime of x naught plus x to the x naught squared to the third power divided by 3 factorial of y to the third differential of x naught plus x to the x naught to the fourth power divided by 4 factorial of y to the fourth differential of x naught plus x minus x naught to the fifth power, which is what the question requested of us, divided by 4 divided by 5 factorial y to the fifth differential of x naught. So the next step we are going to do is to impute the values of each of these functions that we have. So we have that our y of x is equal to, what is our y of x naught? It was given at the question. Recall that your x naught is 1. So your y of x naught is 1. So we have 1. So we have 1 plus x minus x naught. X naught is 1. So x minus 1. What's our y prime of x naught? Our y prime of x naught was gotten to be negative 1. So we have it as negative 1 plus x minus 1 to the second power divided by 2 factorial. What's our y to the second differential? Our y to the second differential is gotten as 3. So our y to the second differential is gotten as 3 times 3 plus our y to the third differential, of course, is x minus 1 divided by to the power of 3 divided by 3 factorial of y to the third power of y to the third differential, which is negative 1. So this gives us negative 1 plus y plus x minus 1 to the fourth power divided by 4 factorial of y of to the fourth differential. So y to the fourth differential is negative 29. So this negative 29 plus the last but not the least, which is x minus 1 to the fifth power divided by 5 factorial times what's our y of the fifth power, which is positive 135. Positive 135. Okay, so just to clear off everything that I have here. Okay, so just to clear up everything that I have here, so I'm just going to write everything out. So I have y of x is equals to 1. Okay, so 1 minus x minus 1. Okay, plus 3 bracket x minus 1 to the second power divided by 2 factorial is going to give you 2. Okay, plus, okay, negative 1, which should give me negative brackets x minus 1 to the third power. Now 3 factorial gives me 6, plus this, which gives me x minus 1 to the fourth power. 4 factorial. 4 factorial means 4 times 3 times 2 times 1, which gives me 24. So 4 factorial gives me 24. Okay, and it's being multiplied by negative 29, so this gives me minus 29. Plus, so we have that, okay, we have x, 135 is multiplying everything, so we have 135 brackets 1 minus x minus 1 to the fifth power divided by 5 factorial means 5 times 4 times 3 times 2 times 1. So this gives us 120. Okay, so this is what it. So the series continues to infinity. So this is the answer to the equation.